Hi everyone, welcome back to the section tutorial discussion ranking cycle. I know some of you have submitted the tutorial, so you can check with the answer of mine and further do your revision. Okay, if you look at the first question, the steam power plant is supplied with dry saturated steam. So if you look at this, dry saturated means X equals to 1, okay? So it's dry, it's the dryness at 12 bar and its contents on 0.1 bar. Remember to convert all of them into kilopascal, okay? So then refer to this because the table is in kilopascal. So change it into kilopascal. Okay, so now we look at the answer. Okay, it's not mentioning feet pump, so we ignore the feet pump, all right? And then since the x1 is 1, so we can directly refer to H enthalpy G at the pressure of 12 bar, which is 1,200 1,200 kilopascal. Okay, and then if you see this, okay, S1, the entropy 1 equals to entropy 2. We can use the entropy 1 and use the value from the table 100. Okay, let's check. 10 kilopascal, sorry, 10 kilopascal. And then we use the enthalpy, the value, the enthalpy here, the value, okay? And then it's equals to S1 because S1 is equals to S2 to get the fraction, the dryness fraction, okay? So after that, then you go back to, because first you refer to this to find your you refer to this to plug in here, okay? To plug in here to get the X dryness fraction. And then after that, you use the same pressure, okay? But this time, you have the fraction already. So you use this enthalpy, okay? Plug it in to get your H2. Because your H3 is at saturated line, okay? So you can use the low pressure, 10 kilopascal, refer to HF, and then you can get your H3. So now, if you look at, you can have H1, you got your enthalpy 2 and enthalpy 3. And remember that I mentioned to you, we ignore the feed pump. So we can use this equation, and seems like we have everything, okay? Plug it in, okay? Okay, plug in all the value, you can get your enthalpy, your efficiency. Is that all right? So next, we look at the question again. The steam at 50 bar, 400 Celsius expand in a Rankine cycle to 0.35 bar for the mass flow rate of 150 kilo per second. Determine power developed, thermal efficiency, and SSC. Okay, so first, we don't know the steam in what condition. The easiest for us is 50 bar. So it's 5,000, right? If you look at this, let me check. This is question number 3. Okay, so it's 5,000. We look at 5,000. Okay, look at the temperature here. Okay, the temperature is 263. Oh, and it's obviously the temperature here is much higher than what you have in this table. And therefore, immediately, we can look for superheated water. It's a superheated condition. Is it okay? Okay, so since we have 5,000 kilopascal, and if you check this is in megapascal. We have to convert it into megapascal. Right, if you refer to superheated water, and if you convert to 50 bar into megapascal, is 5 megapascal. And then because the temperature mentioned is what? 400, right? So you refer to 400, okay? And then this is your enthalpy. This is a 31996.7 is the enthalpy for H1. So indirectly means if I want to redraw this graph, it should be slightly higher up here. It's beyond the out of the saturated curve. Okay, this is just the initial drawing for the Rankine cycle without I know this is superheated or saturated. So I just assume this is saturated. I draw this curve first. It seems like your graph should be here. So it should be somewhere like this. Okay, this is the accurate one. Okay, so the previous one is I try to predict, I just draw first. And turn out that when I check the table at 50 bar, okay, I repeat again, when I turn out to refer to the saturated table, 5,000, the temperature is 263. But the question given is 400. So then I know I have to quickly refer to table A6. And I convert is 5 megapascal. Okay. And then my H1 is 31996.7. Okay. That is the reason I have this number. And I have my enthalpy. And you know that H1 equals to S1, entropy 1 equals to entropy 2. And therefore, I can use my entropy to find my dryness. And then, after that, okay, after my dryness, okay, so I use the fraction to find my enthalpy at 0.2. Okay, and I also need my enthalpy for my H3. So what I can do is, I refer to, this is enthalpy fluid at 0.3 bar. So I find the value. Okay, and then after that, okay, so I can have my H3, and then I put it everything in, and that is my efficiency. And again, in this point, it's never mentioned about the feed pump. We assume the feed, ignore the feed pump. And SSC is 1 over H1 minus H2. That will be quite simple for you. Right. Okay, next. Sorry for the noise. Okay, next is the Rankine cycle with superheated. A steam turbine receives a steam at 15 bar and 350 Celsius and exhaust to the condenser at 0.06 bar. Determine the thermal efficiency. Oh, sorry. Okay, if you look at the question number 3, Rankine cycle with superheated, a steam turbine receives steam at 15 bar, 350, and exhaust to condenser at 0.06 bar. Determine the thermal efficiency of ideal Rankine cycle operating between these two limits. Ideal. So it's ideal. So what should we do? First, we draw the curve. Okay, so we same thing, but you have to remember receive the steam at 15 and 350. So 15, it's refer to the A5 first, 1500. Okay, so it's confirmed it's saturated because it's above this temperature. Okay, so then I quickly refer to superheated 1.5 megapascal because 15 bar is 1.5. So it's between 1.4 and 1.6, and therefore you need to do the interpolation. So I extract the value here, and then it's turned out it's between bar. So you just need to have the H1 at 1.4 plus the H1.1.6 megapascal divided by 2. That's it. So as the S1. And same thing, because you know the S1 is equal to S2, we use the same way to find the fraction. Once you have the fraction, you find the enthalpy of the point 2. And then because the point 3 is HF, is never mentioned anything, is HF, so we find from the curve and you can get the value, plug in everything, and then you can get your efficiency. It's actually pretty much the same, so don't too worry about the the decimal point. All right, remember your SI unit and remember show your equation, everything clearly. All right, thank you everyone. Yeah, see you soon. Bye.